And with this, now I invite Peter Bendix from Next2Sun to please share his presentation. Hi, Peter.
Hello, thank you. Give me a second. Okay, perfect. So welcome also from my side. Thanks for the presentation from Christian. And as you heard, the heterojunction technology is coming up to be LCE efficient or even more efficient within the next year or the next 1.5 years. And for Next2Sun and our racking system, our vertical racking system, the LCE even nowadays is the best for the heterojunction. And I want to give you an insight into where it is coming from, why even these days, Next2Sun is only working with heterojunction technology. So we'll just give you an insight into what our application is and what we're doing. And then I will give you insight into the LCE. So what is a vertical bifacial racking system? We as Next2Sun are the inventors of the vertical racking system, where we do install bifacial PV modules vertically, so like a fence, and install them in rows with a typical row spacing from 10 to 12 meters. And we do have the modules, like bifacial modules, installed vertically to use the power of the sun at the front side of the module, but also on the back side of the module. So with the direct radiance on the back side of the module. This is quite unique, as for common installations you do have a little bit benefit if using bifacial modules, but for our system it's like one of the crucial points to have a high bifaciality of the module available to achieve a high yield. And we do have by this installation, we do have a peak of production in the morning time and another peak of production in evening. And we do have the benefit that we can do agricultural management within the field additionally. So we do have different benefits based on our racking system, and I want to give you an insight into the different topics. It's like a high volume or a lot of benefits you can have, but I want to focus on the topic which is more related to the LCE, as it's the topic for this presentation today. So as I said before, the ground is used in double value. So you can use the ground as before by agriculture, but also you do have the electricity production on the field. With our racking system, we have a fixed tilt system. This is especially for the long-term installation and the reliability of the system. It's very important to have a system which you only want to install once and then don't have further cost which is needed to repair the system and something like this. With our system, like what nobody is expecting, we have a higher energy production than common PV plants. This is because we do use the backside of the PV module in the evening time, and it gives us the possibility to achieve even higher yields with our system. And another point which is really interesting nowadays is we do have the possibility to realize the energy transition with the existing grid infrastructure. Nowadays, it is very often that the grid infrastructure is limiting the installed power of the PV plant, and with our system you can install more power at the existing grid. Yeah, so just as a overview, I can show you where we do have higher performance than common PV plants. Of course, if you go further south or near to the equator, there are common PV plants achieving higher yields. This is completely clear. But in the region marked here in black, the vertical bifacial system is achieving higher electricity outputs than common PV plants. And Next2Sun is only producing vertical racking structure, so it's like our focus on this racking structure, and this is why we are able to achieve even about 30% higher yields than other companies who are like starting to invent vertical racking system nowadays. So with this setup, we do have the vertical agri PV, and we do have the double use and double value. Here you do see a picture of our system installed. Installed at a 4 megawatt plant, one of the plants which had been installed 2 years ago. So just to go give it short insight into the agriculture usage, you do see here the corn mowing within our plants. It's like a really high benefit that you can double use the ground, and you don't have any impact on the water availability. So the rain is not stopped by the PV panels or something else. You only have a loss of irradiance for the ground surface for the corns of 10%, and 90% of the land can further on be cultivated. This is very interesting. But on the other hand, you do also have the energy production of our system. And as I told you, we do have a peak in the morning and the evening when we do install the rows in north-south. So we do have the front side of the panel east and the back side west, or the other way around. And there we do have the benefit by using heterojunction technology, which is one of the topics today as well, because as we do use the backside of the module for power production of half of the day, it is very important for us to have a high bifaciality available. And additionally, for plants in further or in regions further more near to the poles, we do have power production even in winter time, and the snow which is lying on the ground is even reflecting the irradiance and is giving us more power output from our system, where common PV plants are completely snowed and do not produce power at all. So if you do have a look into the power production of our system, it's mainly looking like the blue curve you can see here. So we do have a peak in the morning and a peak in the evening. But what is now very interesting is if you do see the electricity price, which is even nowadays, this is even from 2021, so 1.5 years old, the prices or the peaks of the prices you get for the electricity you produce are higher in morning and evening time. So when producing power with our system, we can realize to get the higher prices at the fair. And if you now compare with a common PV plant, which is producing in summertime at midday, the prices are falling and falling and falling for common PV plants, because in a few years you will not get any money for producing power in summer in midday. So if you do plan a PV system for long term, and of course you do your cost calculations for long term, you will realize that you need another production portfolio than a common PV plant, because within 5 years you will not achieve any money if producing when everybody is producing power in summer at midday. So currently in Germany at all, and I think also in many other countries in the world, the most PV plants are installed as south orientated, and PV is having nowadays the lowest LCOE, but the spot market even today is oversupplied with this power produced. So we need to think into the future and need to think about new possibilities to stay with your revenues and produce the power when it's needed. So here you do see again the production curve of our system and the production curve for common PV plant, just for a comparison at the Apex spot market with pricing. And we currently do have a higher LCOE than common PV plants. This is mainly based on the higher cost for the racking system we do have, but also that our company is quite new and we need to get into the market more deeply to achieve better prices for the racking system. But as you do see here on the right side, it is very important to not only see the levelized cost of electricity, but the market value of the electricity you produce. Because if you do produce your electricity for a lower price, then you are happy, but you won't be able to sell your electricity produced for a good price at the fair, because no one is or wants to use the electricity this time when you produce. And we achieve even these years, like for 2022 we achieved about 10% higher market value. 2021 it was about 6 to 8% higher market value with our system. And this is increasing rapidly, and it's going further and further. And this is why we think as Next2Sun that this is the like realistic next step to to have PV available at the grid. So we do have another point which is also interesting, which I talked about in the beginning. It's the grid availability, because many PV plants or smaller PV plants wants to be connected to grid, but the grid connection is not available. And there we do have the possibility, in case of our production portfolio, that we don't produce additionally to the existing south-oriented PV. We do produce that at other times, so we can install like 3 times the power you would be able to install with a common PV plant. So it is like a reasonable thing to install vertically PV to maintain the grid infrastructure and realize the highest PV power or the energy transition in general. So as a conclusion, with the vertical PV made by Next2Sun, is strongly improving the techno-economical efficiency, so that we are able to realize the energy transition within our structure as easy as possible and as cost effective as possible. So we need less grid capacity. We don't need the ground surface, which is also very important in many countries in these days, that you need to get the ground somewhere available, and it's like a really good benefit to have the double usage of the ground. And even these days we do have a market value which is about 10% higher for our portfolio of production, and it will be increasing rapidly within the next years. So with our system, Next2Sun is an enabler for the energy transition. Yeah, and I hope that all of you just think about Next2Sun within your next plans, if it is an opportunity or possibility to go with this system. So this is what Next2Sun is providing to you. We are like project development, engineering, and also project realization. And thank you for your attention, and thanks for your interest in the vertical PV. Thank you.
Thank you, Peter. That was a very interesting presentation. Now with